Hi everyone, I'm Cheryl. In this problem, we're going to be evaluating the sine, the cosine, and the tangent of a given angle without using a calculator. Now there are actually several ways you can approach this problem. Some people like to use unit circle definitions, others right triangle definitions, and still others like to use tables. In any of the problems, you can use any of these techniques to evaluate the trig functions. The first two examples we're going to look at, we're going to use the table approach. All right, so in our first example, I want to find the sine, the cosine, and the tangent of 225 degrees. Well, I have my angle marked on my Cartesian plane here. And if you notice, when we look at the table, nowhere will you find 225 degrees. So how do we use the table? Well, we're going to look at something called the reference angle. The reference angle is an acute angle that's made with the terminal side of the angle and the horizontal. So for this particular problem, this angle is my reference angle. Because the measure of the entire angle is 225 degrees, it turns out that this reference angle has a measure of 45 degrees. 45 is on my table, and it turns out that all the trig function values of 225 degrees and 45 degrees are exactly the same, with the possible exception of a plus or a minus sign. So we'll go ahead and use our table and say, what is the sine of 45 degrees? Here's 45 degrees. We'll come down, and the sine is the square root of 2 over 2. So I'm going to write down the square root of 2 over 2. Now I did mention that there was a possible difference with the plus or minus sign. Notice that my angle 225 degrees is in the third quadrant. In the third quadrant, the sign is negative. So the sine of 225 degrees is negative square root of 2 over 2. All right, let's try again with the cosine of 225 degrees. Again, the reference angle is 45 degrees. So I'll go over on my table, find 45 degrees, and I notice that the cosine is the square root of 2 over 2. Square root of 2 over 2. Again, I have to be careful. Is it a positive or a negative? The cosine in the third quadrant is negative. So I have a negative root 2 over 2. Let's go ahead and try the tangent. Again, the reference angle is 45 degrees. So I come to 45 degrees, I look up the tangent, and I get 1. So the tangent of 45 degrees is 1. Well, what about the tangent of 225 degrees? It might be different by a plus or a minus. However, in the third quadrant, tangent's positive. So the tangent of 225 degrees is also 1. All right, let's try this process again using a different angle. This time the angle is negative 225 degrees. So from the initial side, I'm rotating in a clockwise direction. Again, negative 225 will not be found on my table anywhere. So I'm going to use the reference angle. Again, I want to use the acute angle created with the terminal side and the horizontal. So I must be talking about this angle. Right? The measure of that angle is, again, 45 degrees. So I'll be using the 45 degrees column in my table once again. So let's see, the sine of negative 225 degrees. Using the reference angle of 45, the sine I know is root 2 over 2. Now let's attach the appropriate sign. In the second quadrant, the sign is positive. So the sine of negative 225 degrees is exactly the same thing as the sine of 45 degrees. Okay, let's move down to the cosine. Here's my reference angle, 45 degrees. The cosine is again square root of 2 over 2. So square root of 2 over 2. In the second quadrant, however, the cosine is negative. So this time I need to attach the negative sign. Last one is the tangent of negative 225 degrees. Again, using the reference angle of 45, I'll come down and I notice that the tangent is 1. So I'm going to make a 1. However, I'm in the second quadrant. Tangent is negative in the second quadrant, so this will be a negative 1. So now you can see that I can evaluate all these trig functions without using a calculator if I use a table. On the next two problems, we're not going to use a table. We'll use a different approach. We're going to try using the right triangle definitions. Okay, now we just got done doing some examples where we were evaluating trig functions without a calculator using a table. You can also evaluate trig functions without a calculator by using some right triangles and also possibly a unit circle. So let's go ahead and look at an example. In this particular case, we have the angle 5 pi over 3. If you look at your unit circle and your triangles, you will not find an angle that measures 5 pi over 3. So we're going to do something similar to what we did in the table problems. We're going to go ahead and look at 5 pi over 3 and say, what's the reference angle? Well, again, the reference angle is the angle created with the terminal side and the horizontal, as long as that angle is acute, which means that this is my reference angle. Now, because I'm using radians, sometimes this gets confusing, but remember, a complete revolution is 2 pi, which using a denominator of 3 is the same thing as 6 pi over 3. So that means that if from my initial side the whole way around is 5 pi over 3, the reference angle must be pi over 3. Okay, pi over 3 is on one of my triangles. So let's go ahead and find pi over 3. It's right here. And the sine is going to be the opposite side over the hypotenuse. The opposite side is the square root of 3. The hypotenuse is 2. So I'm going to have the square root of 3 all over 2. Don't forget, though, we may be off by a plus or a minus sign. So let's take a look. In the fourth quadrant, the sign is negative, which means I don't want square root of 3 over 2. I want minus square root of 3 over 2. All right, let's do the same thing for the cosine. Again, my reference angle is pi over 3. So I'll come over to my triangle and I'll locate pi over 3. The cosine is the adjacent side over the hypotenuse. So that's 1/2. The question is, do I want to leave it as a positive 1/2 or do I need to make it negative 1/2? In quadrant 4, the cosine is positive, so it's fine just the way it is. One more thing, we need the tangent. Again, the reference angle is pi over 3 again. So I locate pi over 3 on my triangle. The tangent is the opposite over the adjacent, which is going to be the square root of 3 over 1. So I have the square root of 3 over 1. Is it positive or negative? Well, in quadrant 4, the tangent is negative. So I have minus the square root of 3 over 1. Now this could be reduced and just written as minus the square root of 3. Because anytime you divide by 1, you just get itself. All right, let's try it again. This time, our problem is 11 pi over 6. The terminal side of 11 pi over 6 lies in the fourth quadrant. And if you look at your triangles or this little unit circle that I've written, you won't find the angle 11 pi over 6. So once again, we'll use the reference angle. The reference angle is the acute angle that's made with the terminal side and the horizontal, which means I'm talking about this angle. Again, remember, the whole way around is 2 pi. Because I'm using a denominator of 6, think of the whole way around as being 12 pi over 6. So if from my initial side to my terminal side is 11 pi over 6, that little remaining piece is pi over 6. So my reference angle is pi over 6. So when I want to find the sine of 11 pi over 6, this time I'm going to go over to my triangles and I find pi over 6. The sine, again, is the opposite over the hypotenuse. 1 divided by 2. So I have 1 divided by 2. However, in the fourth quadrant, the sine is negative. So the sine of 11 pi over 6 is negative 1/2. For the cosine of 11 pi over 6, we'll use the reference angle pi over 6 again. The cosine this time is the adjacent over the hypotenuse. So that's square root of 3 all over 2. In the fourth quadrant, the cosine's positive, so I don't need to make an adjustment. Last one is the tangent. Once again, the reference angle is pi over 6. So I look at my pi over 6 angle, and the tangent is the opposite over the adjacent, which is 1 over the square root of 3. Let's consider the positive or negative options. In the fourth quadrant, the tangent is negative, so this needs to be minus 1 over the square root of 3. So now you've seen two examples using the right triangle way of evaluating the trig functions. Remember, any of these problems can be done with either the triangle method or with the table method. It's your choice. I hope this was helpful. Thanks.